Hello everyone. So we are going to do some numericals on the first module on takeoff weight estimation. So we have seen that how to calculate the takeoff weight. We have seen and calculated different formulae. We have estimated how to find out the range, how to find out the endurance for a given mission profile. So today we will do a problem, right? So to calculate the takeoff weight, a mission profile is given. It's an anti-submarine warfare aircraft. So as we see, there are 7 segments. So 0 to 1 is a warm-up and takeoff. 1 to 2 is a climb segment, 2 to 3 is a cruise segment, and 3 to 4 there is a loiter, and 4 to 5 there is again a cruise segment, and 5 to 6 there is a loiter again, and 6 to 7 is a 6 to 7 there is a land, right? So descent with land, and the given conditions are cruise is of 1500 nautical miles first cruise, second cruise is also same as first cruise, the first loiter is 3 hours and second loiter is 20 minutes. So the given crew weight is 800 pounds and the avionics payload is 10,000 pounds, right? So now we have to calculate the takeoff weight estimation for this, right? So in order to find out the takeoff weight estimation, first of all, we need to calculate the W7 by W0, right? So W7 by W0 is nothing but my Wx by W0, right? Wx by W0, that is number of segments, right? I have complete of 7 segments. So it is W7 by W0, that is W1 by W0 into 2 by 1, 3 by 2, 4 by 3, 5 by 4, 6 by 7. Okay. So that should give me all the 7 by 6, sorry. 7 by 6. So that should give me the W7 by W0. So all the number of segments. And from there, we would be calculating the WF by W0. WF by W0 is nothing but the fuel weight fraction. We know fuel weight fraction is the 1.06, right? So we are taking this for the reserve fuel or the trapped fuel, the allowance, right? Then 1.06 into 1 minus of Wx by W0, which is nothing but W7 by W0. So whatever we calculate over there for W7 by W0, we can rewrite there. Then We by W0 is empty weight fraction. Empty weight fraction is nothing but A into W0 power C into KVS, right? So this A and C are constants. We are going to take that from a chart, right? We have historical trends given. From that, we are going to write A and C the constant and KVS is 1. Right? If it is fixed, it is 1. If it is a variable speed, then the value is different, right? So then finally, we are going to calculate the W0, the takeoff weight estimation, right? So the takeoff weight estimation is going to be, the formula is, we have seen this in the previous classes, it is W crew plus W payload in the numerator by 1 minus of WE by W0, that is your empty weight fraction, by WF by W0, that is your fuel weight fraction, right? So first of all, I'm going to find out W7 by W0, then fuel weight fraction, then empty weight fraction, then substitute all of them here. But what are the unknowns? The unknowns to me is my W0, right? So W0, what I do is I take a table, right? So we do some iterations here. What are my iterations? I am going to guess a weight, right? It would be my guess weight, which is W0, right? Then for that guess weight, the guess weight is going to be a 4 times of all these particular numerator, right? Crew plus payload. So I'm going to guess a weight of 4 times of that numerator, which is crew load and payload, crew weight and a payload weight, sorry. Right? Then for that, I am going to substitute in my empty weight fraction, right? So then I'm going to get a particular empty weight fraction for the guess to W0, right? Now from this again, what we are going to do? We are going to finally calculate your W0. So that would be my calculated W0, right? So from there I get a calculated W0 and I continue till the values converge or till where the values are going to be approximately similar to, right? So I'm going to converge it until I get a same number from the guess and for calculated weight, and I then understand that yes, this is my calculated W0 that's required for a particular mission profile, right? So let us start doing the problem. So the given, now what is given to me? It is saying anti-submarine warfare ASW aircraft for given a cruise conditions and loiter conditions, payload and a crew weight with the high bypass turbofan and max is given, A is also given, L by D max is saying 16, and so that it is given in terms of nautical miles. So when we are calculating, we calculate in terms of feet here, right? So 1 nautical mile, for our reference we have written it as, the value has been written here, so it is 6076.12 feet, right? So we'll do the problem. So first, in order for me to find out W7 by W0, so W1 by W0, so and some of them are being considered as a defined numbers. So the first one, W1 by W0, so the warm up and takeoff segment is a constant definite number which is 0.970, and for climb it is going to be 0.985, and the landing it is going to be 0.995, right? So let us just write that here. W1 by W0 is going to be 0.975. 2 by 1 is going to be 0.98. Then the final is going to be 0.99, right? So apart from these, what are we supposed to find out? I have to find out W3 by W2 and W4 by 3 and 5 by 4, right? So what are these? 3 by 2 is my cruise segment, 4 by 3 is a loiter, 5 by 4 is again a cruise, and 6 by 5 is a loiter, right? Are we missing 6 by 5? Yes. So this is my 6 by 5 here, and then we have 7 by 6. Okay. So we have 2 loiters and 2 cruise conditions to find out. And for cruise segment, what is that we have said? In order to find out for a cruise segment, that is nothing but your range, right? What is my range formula? We have said my range formula W3 by W2 is nothing but your exponential of minus of range into C by velocity into L by D, right? So that is your range formula during cruise segment. So now what is this? So range, how much range is given here for a cruise segment? W3 by W2, it is cruising for 1500 nautical miles, and we know 1 nautical mile is 6076.12 feet, right? So therefore, what is it we do? Range 1500 into that particular nautical miles, converting into feet will be your R. Then what is C? C is my specific fuel consumption. Now we have already discussed in our previous classes, right? So specific fuel consumption for a high bypass turbofan, I need to find out, right? We have a table that has been given already, right? So let us just go back and see the specific fuel consumptions for high bypass turbofan. For a cruise it is 0.5, for a loiter it is 0.4 per hour it is, okay? So let us just write down here. C for a cruise is 0.5 per hour. C for a loiter is going to be 0.4 per hour, and hours are going to be converted into seconds. Okay. So I know range, I know specific fuel consumption. Then V. From where do I get V? Mac is given, right? M is equal to V by A. M is equal to V by A. I think M is given and A is given already, right? So M is given as 0.6, A is given as 994.8 feet per second. So all the conversions are correct. So we can calculate V from there. So V is obtained. Then once you have V, then all I have to find is what? L by D. Right now, how do I find L by D? What is my L by D estimation? L by D estimation. Now again, let us go back to the table and let us see. Right, so yes. So L by D estimation for a jet, it is 0.866 L by D max. For loiter, it is L by D max, right? So let us write down. So it is going to be L by D for a cruise. It is 0.866 into L by D. Then for loiter, it is going to be simply L by D, right? So how much of L by D is given to us? It is 16. So it is going to be 0.866 into 16. Then it is simply 16. Okay. So now we have W3 by W2, that is for a cruise segment. The range formula, according to the range formula, I got the mission segment W3 by W2, we get a calculated value here, right? So this is also done. Then what is 4 by 3? My 4 by 3 is loitering for 3 hours. So 4 by 3 is nothing but what? Your 4 by 3 is nothing but your loiter segment, right? Loiter segment is nothing but endurance, right? And we have already said the endurance formula, right, in the previous classes. So it is going to be exponential of minus of, what is it, right? So we know the exponential of minus of r into range. It is not, there is not going to be a range, right? So it is going to be simply minus c by v into L by d, right? Correct. Let's just go back and see the formula. Yeah, so it is e, right, exponential of minus endurance into c by L by d, right? So from there, see, while solving a problem, we need to check all the data, right? Endurance into c by L by d, right? How much endurance is given? It is loitering for about 3 hours, I guess. Yeah, so 3 hours. So endurance 3 hours need to be converted into seconds, right? In terms of second. And specific fuel consumption for, in loitering case, for this particular anti-submarine warfare, we have written somewhere, I think. Yeah, it is 0.4 per hour. We have checked it already. So that is going to be C. Then what is L by D? L by D for a loiter is nothing but L by D max, which is nothing but 16. We just saw it, right? So from there, we should also be getting the value of W4 by W3, that is the loitering segment, right? Then what is the next segment? W5 by 4. Right, what is 5 by 4? Cruise, again, the range is same, right? It is same 1500, so not necessary to calculate again. It is going to be the same value, right? W5 by 4 is nothing but your W3 by 2 because my range is same. Then what is next? 6 by 5. 6 by 5, you are loitering for 20 minutes, right? So let us calculate here. 6 by 5, loitering for 20 minutes. So I'm going to convert this 20 minutes into second, right? Replacing here, endurance is 20 minutes to be converted into seconds into specific fuel consumption again for loitering to 0.4 per hour by L by D is going to be 60, right? So we'll get a value of W6 by 5. W7 by 6 I know because during landing it's a definite number 0.99, right? So therefore, now multiplication of all the segments should give me W7 by W0. Then from there, I know how to calculate fuel weight fraction, which is 1.06. This is the allowance that we are going to consider for a trapped or reserved fuel into 1 minus of W7 by W0 value, what we attain here. Then we know empty weight fraction. Empty weight fraction formula is ANC to be constant, W0 into KVS. Now what is ANC? Right? Let us see what is ANC. Now let us go back to the historical trends of calculating the empty weight fraction and let us see. Yeah. So how much it is? It is going to be a so from here, see, all the data is given to you, right? If it is unpowered, you can calculate, you can note it down your ANC values. If it is a jet trainer, if it is a jet fighter, it is an anti-submarine warfare, it's a bomber aircraft, then you know your values. If it is a jet transport, you know your values, right? So from there, we write it's an anti-submarine warfare, a bomber aircraft, so it is going to be 0.93 and minus 0.07. So A is going to be 0.93, C is going to be minus 0.079, right? So then KVS, it is a fixed one, so my KVS is going to be 1, right? So what is the undefined term? W0. So I still don't know what is W0, so W0 is going to be just that way, right? Then finally, so W0 here, right? So W0 is going to be the formula we have obtained, that is crew weight plus payload weight. So crew weight and payload weight is given, right? So it is 800 pounds plus 10,000 pounds, so it is 18,000 pounds, right? By 1 minus of WE by W0, the value in terms of W0 you're going to attain minus WF by W0, you have a certain value, right? Now then, next what we do is we take the iterations, right? Now we guess. Now how much do I guess? I'm going to guess of a 4 times of the numerator, right? 4 times of crew plus payload should be my guesser value, the first guess value here, right? So supposing if the first guess value is some 50,000 or 40,000 according to the calculation, then with that guessed weight, I am going to calculate the WE by W0, right? So where is my WE by W0? Okay, so this is my W by W0. That is A, I already know. C, I already know. KVS is already known. W0, you're going to substitute by your 50,000, how much you're guessing. Then I get a certain value here, right? Certain number here, right? So with that number, I should be able to calculate this W0, the calculated value, right? Now I continue this. My iterations are going to continue until until it converges, right? So until I get some similar number, my guess weight is going to be almost equal to my calculated weight. So that is the calculated weight which I assume that it is going to be for a anti-submarine warfare according to the given parameters, right? So that is how we go and calculate a takeoff weight for any given mission profile. Now the same thing for the same problem, what we're doing is ASW is anti-submarine warfare here, right? For the same problem, the range is going to be different now, right? So the range we are going to change it for a what is it? Initially the range was 1500 nautical miles, right? So now 1500 nautical miles is going to drop down and come to 1000 nautical miles, and the other one is going to be 2000 nautical miles, right? Now I want people to practice it, right? So for a range of 1000 nautical miles, we're going to calculate again all of them, right? The only change that we see is my W3 is W3 by W2, a given range here it was 1500, but except here it is going to be 1000, and for the next time it is going to be 3000, right? So we are going to calculate for a two different set of ranges, and we are going to make a plot here, right? So my plot is going to be range versus takeoff weight. It should be something like this, right? So 1000, 1500, then 2000, right? Is that so? Yes, 1000, 1500, and 2000, right? So we go and plot how it is going to be for a given different set of ranges for a takeoff weight, for a calculated takeoff weight, right? So then similarly, for the same anti-submarine warfare, now we are going to assume the payloads be three definite payloads, that is 500 pounds, 15,000 pounds, and 20,000 pounds, right? So it's only that the loitering segment, whatever it was, right? The loitering segment is going to change, right? So your loiter here is going to be 500, then it is going to be 15, and then it is going to be 20,000, right? So we calculate that. We also calculate that, and we get a graph also again, takeoff weight versus payload, okay, for three different payloads, right? So I want you people to take it as assignment and finish it for a range trade-off and payload trade-off. So next we will see another problem, right? So initial sizing of a civil aircraft. It is going to be a Boeing 787, right? A Boeing 787 aircraft has been considered. For that, a crew weight given as 1437 kg, and the maximum payload weight expected is going to be 21347.2 kg, right? And the specific fuel consumptions are already mentioned here, right? It is not, we are not going to go and check the table and calculate. So C for a cruise is given, C for a loiter is also given, yes. So C for a cruise and C for loiter is given, and wing aspect ratio is given, which is 10.586. Now this is different from the previous problems that we have solved, right? So I see a wing aspect ratio here. I see wing aspect ratio here because I don't have L by D max. So that is what we are going to calculate. In the previous problem, L by D max was given, right? So here from the wing aspect ratio, we are going to check the graphs and we are going to estimate your L by D, right? So therefore, let us see. Yeah, so this is the mission profile, okay? So now from this mission profile, we see that 0 to 1 is warm up and take off, then 1 to 2 is climb, then 2 to 3 is my cruise, then next is descent, then I have a loiter, then I have a diversion also, right? Diversion of the fuel, then I have approach and landing, right? So and the altitude values are given here, right? So for a cruise altitude, the cruising altitude is going to be 37,000 feet, right? The Mach numbers are also given here. Mach number for a cruise is going to be 0.850. Then the range, right? A cruising range. Cruising range is what? W3 by W2. W1 by W0 is a predefined value. We know that. W1 by W0 is going to be 0.97, right? Then 2 by 1 is also predefined, which is 0.98. Then what we're supposed to find out is 3 by 2, right? So for 3 by 2, how do I find out 3 by 2? Exponential of minus of range into cruise by V into L by D, right? Now range. This particular range is given as 8,000 nautical miles. I convert the nautical miles into feet first of all. Then specific fuel consumption already given, right? Already mentioned. Then I have to find out V. In order for me to find out V, I have a Mach, M and A, right? I get V from there. Then L by D is something that I have to find out, right? So let us see that. Before that, well, let's just see the mission profile. So next is my 423. 423, yes. So W4 by W3. Then 5 by 4. 5 by 4, again it is a loitering. So loitering you need to find out. Then I have a next is 6 by 5, which is going to be a diversion, right? For a diversion, again for loiter it is given. Loiter duration is going to be 30 minutes. So for 30 minutes, I'm going to calculate, sorry, exponential of minus of endurance into C by L by D. So endurance is going to be 30 minutes, convert them into seconds. C is known for loiter, L by D is what we have to find out from here, right? Then again, we have a diversion altitude given because I have a diversion segment also over there. For a diversion segment, my altitudes are given, right? So it is 22,117 feet. Then for that, I have a diversion Mach number also. I have a range also given to me, which is 200 nautical miles. For that diversion segment also, I'm going to find out what is it, 6 by 5, right? For 6 by 5 also, it is a formula going to be minus of range is 200 into, you have to convert nautical miles to feet, right? So it is nautical miles, let me write that. Then it is a special fuel consumption by V into L by T, right? So we find out that. Then 7 by 6 wheel. 7 by 6 is going to be a constant number, 0.99. Okay. So let us see that. So first of all, we know these formulas now. We know W naught is going to be W payload plus W crew plus fuel plus WE. I write in terms of fraction and I bring out that finally my W naught is going to be something like this: crew weight plus payload weight by what? By 1 minus. Right? It is going to be 1 minus of E by 0 WF by W naught. So this is my W naught finally, which I have to find out. Right? For that I know different formulas. Right? Then K is a fixed one. So fixed it is 1. A and C are going to be constant, which we are going to go and check over there. So jet transport A and C I have written here, but let us just go and see. Go and see the table. What is A and C? Yeah. So for jet, we are saying it is a Boeing 787. So it is 1.02 and it is minus 0.06. Okay. So that is going to be my A and C value. Special fuel consumption not necessary to find out because it is already given in the question, right? All we have to calculate is L by D. So just continue from there. So first of all, I'm going to find out, yes, W7 by W naught is going to be found out because how many segments do I have? 1 to 0, 2 to 1, 3 to 2, 4 to 3, 5 to 4, 6 to 5 and 7 to 6, right? So I calculate for considering all the given ranges, all the given endurance and all the Mach numbers, I'm going to calculate and I'm going to find out, right? So W4 by W3 is going to be 1 because we are assuming that does not consume any fuel here, right? So it is dissenting. So we are expecting, we are assuming that there is no fuel that has been consumed over there. So we are writing that particular 4 by 3, 4 by 3 as 1. Okay. So then, so let us calculate first. So 3 by 2. 3 by 2, I know cruise range given as 8,000. So convert nautical miles into feet. Then cruise Mach number for a cruise is given 0.85. From there I can find out the velocity, right? Specific fuel consumption is already mentioned, right? Therefore, all I have to find out is only L by D max, right? Because for a jet it is 0.866 into L by D max. For a cruise, for a loiter it is simply L by D max, right? So this we know, but we have to find out L by D max by given a, they have given you something, right? What is it they have given you? The wing aspect ratio is given, right? So from there we need to find out this. And similarly, your loitering segment also, endurance is given 0.5 hours, convert it into seconds. Then you know it is going to be exponential of minus of endurance, exponential power minus endurance into C by L by D, right? So for a diversion segment also it is going to be the same except that they have given the range. Range is given, diversion Mach is given, right? Then we, C is already mentioned, A is known, so we can find out that. So before finding out that, I want to find out L by D max, right? How do I find out L by D max? So in order for me to estimate the L by D max, we have something here, right? So wing aspect ratio is mentioned in the question, which is 10.586, right? So now from that, my weighted aspect ratio is going to be wing aspect ratio by this, right? By S weight by S reference. So now how did I get that particular number 6? Let us just go and see that. Yes. So this is my S weight by S reference, right? S weight by S ref. So we have different configurations here, right? So we have different configurations. So now, what is our aircraft? Our aircraft is Boeing 747, right? The question given to us is Boeing 747. Now for Boeing 747, it is 6, right? My S weight by S ref is 6, right? So therefore, I write my S weight by S ref to be 6. So that is 6. Wing aspect ratio given as it is given in the question 10.586. So I can calculate the weighted aspect ratio. So I get my weighted aspect ratio as 10.586 by 6 should be 1.76. Now with this, how do I calculate L by D max? Right? Now with that, again let us see one more chart. Yeah. So for the for in order to find out S weight by S ref, I consider whatever the configuration that is mentioned to me. If it is a Boeing 747, then I take Boeing 747 value, that particular S weight by S ref. Then having that value, now let us calculate this, right? Now to calculate the L by D max. Now I already know weighted aspect ratio attained as 1.76, right? By calculating. Now from 1.76, if we draw a straight line to your Boeing 747, then we see that it is 21, right? So 21. So as such, you can take any of it. So if it is given, you are going to get attain value of 2.1 or whatever. So I draw from that line straight, and whatever my aircraft is, right? Accordingly, I go and draw to it and take the value of L by D max. If it is a military jet, Gulfstream, or whatever it is, right? So I first of all I calculate weighted aspect ratio. Then from there I get my L by D max. In order for me to get a weighted aspect ratio, first of all I need to get my S weight by S ref, right? So therefore we see that my L by D max is 21, right? Now for cruise segment, what is it? We have said jet engine, jet engine. So for cruise segment, it is 0.866 into L by D max, as we have seen in the previous numerical also. So now it is 0.866 into 21 is what I have estimated, right? So that is going to be my L by D for cruise, right? For loiter, it is simply 21. Okay. So therefore, I go and calculate that. I get 3 by 2. Then I get for a loitering segment also. Then for diversion also, I have a diversion segment here. Right, for divergent segment, I have different range, I have different Mach number. So for that L by D, I am going to calculate and I get a value of 6 by 5. Right. Now I believe all the mission segments we have obtained: 1 to 0, 0.97, 2 to 1, 0.98, 3 to 2 we have estimated, 4 to 3 we are assuming that there is no fuel is been consumed, so it is 1, 5 to 4 for the lighter segment we have estimated, 6 to 5 diversion segment is also similar as the cruise segment we have calculated, then 7 to 6 we know it's a definite number, which is 0.99, right? So therefore now we have all the mission segments, right? Now we should be able to calculate 7 by 0. Yeah. So that is my 7 by 0. Please try to calculate and check, right? So when you calculate all the segments, all multiplication of all segments should give me 0.5737. Then from there, I know how to calculate fuel fraction weight. It is 1.06 into 1 minus of W7 by W naught, right? Then from there, I get WE by W naught. Sorry, I have missed that. So WE by W naught is nothing but your A into W naught power C into KVS. We have seen for jet, right? So for jet A and C values we have seen. We will write that W naught is going to be an undefined number itself still. Right now for that, I'm going to write W naught. So we are going to do some iterations. Now the guess weight, we have said that is 4 times your numerator. So 4 times my numerator is going to be crew and payload weight is given. What is crew and payload weight? Okay, so the overall weight is given 21347.2, that is payload, right? So from there we are going to take it right? So we are going to calculate the value, and my 4 times of it is going to be my initial guess, right? Now for that initial W naught, I'm going to calculate the WE by W naught, right? Substitute your W naught here and get the value. From there, I'm going to calculate my W naught, right? The calculated W naught, right? Again it is going to be the same, right? So again, when you go and calculate now the answer, right? So it is going to be, again, it is going to be different, right? So now again I find out the WE by W naught, then again your calculated weight, right? So this procedure is going to be repeated, right? So procedure is going to be repeated, right? So now what is the second is been shown here? The first guess weight plus your calculated weight, right? Okay. So into your 0.5 or by 2, right? So by 2 should give me your guess weight. That is what I am going to guess for a second time, right? You guess for the second time and you get your WE by W naught, and then you're going to get a calculated weight, and again it is going to be your now this number, right? So this value, which is your 30516 plus this value by 2. Then again you get a W by W naught, you're going to calculate W naught. Then finally at a point I get the same, it is going to be the same number. Similarly, almost you're going to get 67,000 or so, whatever, right? So approximately it is going to be 67,000 or whatever, right? So 67, 5 or whatever, so on, right? So that is where your convergence stop, and that is where you say that now this is my calculated W naught for a given mission profile. Okay, so for a given mission profile, for a bomber 787, my calculated W naught is going to be that, and that is going to get from your iterations, and iterations we are going to solve from all the different mission segments. You solve all your mission segments, you solve your mission fuel fraction, you solve your estimations, which is your empty weight estimation, and then go to the iterations. Iterations are done by a calculated way. Then you stop when they convergence, right? So that is how we are going to calculate your takeoff weight for any particular aircraft that has been given to you, but keeping in hand with you all your tables ready. All the tables ready meaning uh, what is it I want? I want specific fuel consumption. I need to know what is specific fuel consumption during cruise or during loiter for a different type of an aircraft. Also, I want L by D max, right? So L by D max for a cruise and for a loiter again. Now, if L by D max is given, well and good. If it is not given, then again I have to go and have look into my graphs of S weight by SRF. Then I go and check for my L by D, right? So that is how I want. And also for your empty weight fraction, we want A and C, right? The constants, right? For a historical trends of an aircraft is given. So the constant values are all determined over there. So we take these and substitute in your empty weight fraction, and that is how we go and start calculating your takeoff weight, right? So that is all for today. So here we close. Here we are closing the numericals of how to calculate the takeoff weight. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.